Assalamu alaikum. Now this video has the information about random variable. We have studied variable, and now the next term is random variable. It is a different type of characteristic which a variable has. So the simplest definition for a random variable may be like this. Okay, if a variable x is so defined, if a variable x is so defined that its all observations x1, x2, x3, xn have their corresponding point probabilities like p1, p2, p3, pn. This p1 is probability of x1, this p2 is probability of x2, and this pn is probability of xn, because these are the one to one, and this point x1, this probability p1, this for point x2, this probability p2. That is why they are termed as point probabilities. And the condition for these point probabilities is like this, such that the summation of pi should be 1. This condition must be satisfied. Then this variable x is called a random variable. So this is the simplest definition of a random variable to understand the basic difference between a simple statistical or algebraic variable and a random variable. The simple statistical variable or algebraic variable, they have simple values x1, x2, x3 like this. But there is no information about what is the probability of x1, what is the probability of x2. They are simple variables. Random variable is defined like this. In a tabular form, if we write a random variable, so we will write like this. This is x, this is p. X is having different observations x1, x2, x1, x2, x3, xn. And the corresponding probability of x1 is p1, p2, p3, pn. We can understand this situation by a simple example. Okay, if a number shown on a die when it is thrown be a random variable, then see this information. X is a number shown on a die. When we throw a die, we can get 1 or 2 or 3 or 4 or 5 or 6. And we know, everybody know that this is the sample space for a random for a die when we throw. And this sample space gives the probability of 1 over 6. 1, 2, 3, 4, 5. 1 over 6. Probability of x value 2, 1 over 6. Probability of x value 3, 1 over 6. All 1 over 6. So this is the, and these point probabilities are meeting the condition when we are adding, we are getting 6 over 6. This is 1. Yani this is an example of random variable. This x is random variable. Why it is random variable? Because every observation is having corresponding probability. If any of the observation is denying to have a probability, or we are not able to calculate the probability for any of the point value here, then we, in that situation, in that case, we cannot call this x as a random variable. Okay. Now I have some points to discuss for a random variable. Okay. Any variable x which has probabilities for some observation and for other observations, if probabilities are not available, then this x cannot be named as random variable. Simple. A random variable gives an idea about a population that is called a probabilistic population. What is the definition of population which we have discussed in the very beginning of this course? Population is a complete set of observations pertaining to that variable. That is called a population. Now a new term comes, the probabilistic population. A complete set of observations pertaining to a random variable will be called a probabilistic population. And if we discuss the nature of the random variable, there are two types of random variable: discrete random variable and continuous random variable. In this section, we are dealing with the discrete random variable. Continuous random variable we will take, inshallah, in some other class. And what we mean by probabilistic population? Probabilistic populations, either with the discrete or continuous random variables, need to be characterized by their parameters like mean, variance, standard deviation, movements, and many more things. This is the important point here. This is important point here. Why we are so much worried about random variable? Why we are so much discussing about? Why we are not stick ourselves with a simple variable? Here is the point. Because there are many situations where the simple variable does not work, we are bound to consider its probabilistic nature. We are bound to consider the probabilistic nature of the variable. So that becomes a random variable. And when it becomes a random variable, it means they are having, every observation is having their corresponding point probabilities, and then they leave the nature of simple population. They come under a specific nature. Now the probabilistic populations have an specific characteristic because of the probable involvement of the probabilities for point values. So our objective actually, we are preparing ourselves for this thing. Okay, our objective in coming section is how to characterize a probabilistic population. Actually, the basic purpose of study, the basic purpose of studying statistics is how to characterize a population, how to characterize different populations under different situations. This is our main objective of the study. Actually, for this only one sentence, how to characterize a population, we are having many courses. Math 250, Math 255, 375. Many courses are designed only just for this line to fulfill this objective, how to characterize a population. Characterization of a population, the basic meaning of characterization of a population means okay, what is the arithmetic mean of this population, what is the geometric mean of this population, what is the standard deviation of this population. They are called actually characteristics of the population. Also in general, we call them the parameters of the population. So this is our objective actually. Now, another thing, okay, probability mass function. This is the major important term which we are going to deal in our new sections. So, we must understand the meaning and the purpose of this function. What is probability mass function or PMF? A function Px. I am using the simple definitions, and in the coming sections we will be using mathematical definitions, the higher concepts of these functions. But here try just to understand the basic concept. I am writing the basic definition. A function Px defined for a random variable in such a way that it provides point probabilities for each observation of random variable x, subject to the conditions that in no case Px is negative. Px is positive for every x, and whenever we add all Px, we get 1. These are two conditions on a function to be called as probability mass function. For example, if this is a very popular probability mass function, we will see later. Px is equal to ncx, px, qn minus x, and x has this range, x equal 0, 1, 2, 3, 4, 5, n. This is called a binomial function. We will refer this later in our later section. This is called a binomial function. Every probability function will be defined with this condition. If you say this is a probability mass function, immediately the second question should come to your mind. Okay, what is the range of x? So this is the range of x. Without range of x, we cannot have a probability mass function. Okay, is a probability mass function of a random variable x. Now I write one example. If this n is 3, because the maximum value x can take 0, 1, 2, 3, 4, 5, n. If this n is 3, yani x is taking value 0, 1, 2, 3. If n is 3, that is x has values as x equals 0, 1, 2, 3. Then I will see how this function is behaving to calculate the point probabilities. So taking the value of p 1 by 2, q 1 by 2, whenever we will deal any function like this, so this n, p, q, they are called the constants of the function, and these constants will have always some numeric values, and this x is a random variable. So other than x, everything will be a constant. Other than x will be variable and everything will be a constant. So with this n equal 3, this is the form of function. With n equal n equal 3, actually if I write the function, it will have this shape. N equal 3 cx, and p is 1 by 2 power x, and q also 1 by 2 power 3 minus x. Now this will become the form of x for x equals 0, 1, 2 and 3. We will write like this. Now how to calculate these point probabilities in a tabular form? X has value 0, 1, 2, 3. Px will be according to this function. NC0, this 0 is here. 1 by 2 fixed, 1 by 2 fixed. Power x, x is 0. Power n minus x, n is 3 minus x, x is 0. So this gives this calculation. 3C0 over 2 power 3. 2 power 3 yani this is 1 and this 2 power 3. 1 over 8. Similarly, 3C1 1 by 2 power 1, 1 by 2 power 3 minus 2. This 3C1 over 2 power 3. Again 3 by 8. Similarly, all calculations, when we add, we get 1 by 8 plus 3 by 8, 3 by 8, 1 by 8, it gives 1. Okay. So this is the form of a random variable. It will have point values, it will have the corresponding point probabilities, and I will continue the same topic inshallah in next topic.